using our methods. Alright, yeah, I see what it is. You're not responsible for number 3. Did not realize that yesterday. I mean, very slim, yeah. That's got inverse trig and like a double plug-in. That's a beast. Okay. 7 is good. So don't worry about 3. And then I already told you don't worry about 4 and 10, right? Alright, so 7. First thing I'm going to do is rewrite it. So there's not like the square root on the bottom. So, and I would also write the sec of x squared like that. I think it's both, like they mean the same thing, and I think most people, it's easier to tell like big guy, little guy if you write it this way. And then tan of x would be to 1 power if it's up on top. Negative 1/2, right? Alright, so this is one where you gotta choose. Because like this could be your big and this is your little, or this could be your big and this is your little. But what we want is for like the du to not necessarily be there, but like almost be there. So let's say I made u equal to sec of x. So in my head, in this attempt, I'm making 2 the big guy and this the little guy. And then I want to take the derivative here. So du would be what? What's the derivative of secant? Sec tan. Good job, everybody. It would be sec tan. So I'm not like I'm going to replace this with a u and that with a square. Can I turn this here into my du by multiplying by only a constant? Like can I multiply tan of x to the negative 1/2 by a number and turn it into sec tan? No. So what does that tell me about my choice for u? It was a bad choice. I should not have chosen u. I should have chosen someone else. So let's try the other way. Let's say u equals tan of x. Alright, well if u equals tan of x, then it'd be like u to the negative 1/2, and I gotta see if this can like transform into du. So what's the derivative of tan? Go for it, yeah, I'm waiting for anybody to say anything. No, because you have to do quotient rule. Still waiting for the derivative of tangent. Secant squared. Good job, everybody.
That would have helped a lot last time.
Do you see how like you can't do these if you don't have those memorized? Like you're basically stuck. If you don't know, you're screwed. But then here's the thing. Now that I've got this set up, if that's my u and u to the negative 1/2, I need this to be my du. Can I transform this into this by multiplying by a constant? Or just 1, right? Like it's already there. So then I can rewrite the problem right away. So the secant squared of x and the dx just turned into du. And then u is tangent, so I have u to the negative 1/2. And there's no constant out in front because I didn't have to like adjust anything. A couple people asked something. Does that help figure out help you figure out how to tell which is the big and little? It's just kind of trial and error. The more you do, the more you'll be able to see it quickly. But like if you don't know the derivative of tan and secant squared, you're gonna miss this problem. Like period, point blank, you're going to. Show the derivative of what? Yeah, can I do that like separately with you after?
Yeah, that's fine.
Okay. So I'm not done with this, right? I still have to integrate. add 1 to the power, multiply by the reciprocal of the new power, so 2, and then put your plus c, and then you just put the u back in, so tan of x to the negative 1 half. To the 1 half. Is that okay for someone? You said 7 too, right? We're good. What else? I'll do them all if you want, or whatever. Tell me what to do. Yeah. To the du. So like that's like so if I had just regular like integral of 2x times dx, you would tell me that's x squared plus c, and that dx disappears. This is basically the height of your rectangle, and this is the base of your rectangle. And when we integrate, we're taking the area, so we don't need to worry about the height and the base anymore. It's like dx represents the derivative, and we're going up a level, so we don't need that. So it does just disappear. It is kind of weird, but it just goes away. 8, yeah. So, first of all, I'd rewrite it. So I'm going to x. That dx is going to go like off to the side. And then I'm going to bring this up, so it'll be 1 minus x squared to the negative 1 half, because square root it and then bring it upstairs. Is that part okay? Just the rewrite? Alright, so then I got to figure out what u is. Well, if I make u equal to x, then du is 1. And can I turn that into 1 by multiplying by a constant? That's not going to work. So I'm going to try, I'm just trying to talk through like options here. So I'm going to try making this my u, the 1 minus x squared. That makes du equal to negative 2x times dx. But I don't have negative 2x times dx up here. I have regular old x. So what do I need to multiply this negative 2x to turn it into a regular x? Almost. Negative a half, right? So multiply everything in here by negative a half, and now it'll say like negative 1 half du equals x times dx. And now I know what x times dx is, so I can replace x times dx with negative 1 half times du. Okay. And then u is 1 minus x squared, so then this becomes u to the negative 1 half. And then I can just do my regular power rule, so I add 1 to the power, which makes it 1 half. I multiply by the reciprocal of the new power, so a positive 2 times this negative 1 half is a negative 1. And then don't forget your plus c. And then you shove the x's back in place for the u's. How's that for 8? Alright. What else? I can. I would love to. Alright, so the integral of ln of x to the 5th power, I don't want a fraction, so I'm going to bring that up, which would make it x to the negative 1st times dx. Is that good? So, what do you think the little guy is? What do you think u is? ln of x. So u is going to be ln of x. You don't have to raise your hand. That's mostly for Gavin instead. You can just shout. I appreciate it, but if that rule were in second hour, you would just shout. So, okay. So then what is du? Looking at me with a blank face, you will not be able to do this problem. What? It's 1 over x. So the derivative of ln of x is 1 over x. Well, isn't that 1 over x? So the derivative of ln of x, like, couldn't I just say it's x to the negative 1st? Because 1 over x and x to the negative 1st are the same thing, right? So then I'm set. I have x to the negative 1 times dx. What am I going to put in place of it? Is du. So I didn't have to adjust by a constant, so there's no number out in front. And then this becomes u to the 5th. You with me? We good? Stop me if we're not. Like, please. How are you? Okay? minus c, and then put your ln of x back in there. Remember, you can always check it too. If I gave you this instead of take the derivative, you would do 6 times 1, 6, which would cancel. Leave the ln of x, you'd reduce the power by 1, so now it's a 5. And then you'd multiply by the derivative of the inside, which is where the next to the negative 1 comes from. Okay, for 9, 10 we skipped. Should I do 12? 12 looks like it would cause some issues. Okay. So first of all, I'm going to rewrite it. So I would bring this 4 minus ex up to the top and make it to what power? To the negative first. Can you raise your hand, please? I could. Just kidding. So what is u? That's a question we're all trying to answer, right? What are you? Zach. It is. And that's your big guy, and then we gotta see if this matches up. So u is gonna be 4 minus e to the x. Well, du is the derivative of that. So what's the derivative of 4? Nothing. And the derivative of negative e to the x would be negative e to the x. Because the negative just drops. Derivative of e to the x is e to the x. There is a chain rule piece there, but the derivative of x is just 1, so we don't really have to worry about it. So this up here says e to the x times dx. I want it to say, I'm sorry, so I want this to say e to the x times dx. So what do I need to multiply by to make that happen? Negative 1. So multiply everything by negative 1, which would make it say negative du equals e to the x times dx. So then instead of e to the x and dx, I'm going to put the negative sign out front and the du at the back. And then I have u to the negative first power. Okay. Then I'm going to go through my regular rule. So I add 1 to the power, which is 0. Multiply by the reciprocal. Crap, we can't take the reciprocal of 0. Oh yeah, that's natural log. So the natural log of the absolute value of, I'm kind of running out of room, so I would put a u there to start with, right? But then what am I going to replace that u with? I'm going to put the 4 minus e to the x, right? So is that okay for that one? I'm going to now try again to show you the other method, because I think it might help some people like click in what's going on. But I know some people yesterday told me they covered up their ears when I was explaining the other method, and that's fine. Like if you are rolling with this, and you want to roll with this, you can sit there and like hum songs in your head so you don't hear me. But I'm gonna try for those that I think that it might help. So let's say I was doing number 8. I would get this. So that's my rewrite. So this is your big, this is your little, and this is little guy prime. I don't know yet. What's the derivative of the little guy? Almost. Negative 2x. So I need this to be a negative 2x. So I'm going to make it a negative 2x. I'll put a negative 2 there. But if I put a negative 2 on the inside, I have to balance it out by putting the reciprocal on the outside. Now, I do have little guy prime, and I'm happy. And little guy prime just goes away. Once you have it, it just goes away. Your job now is to integrate the big guy. So you'd add 1 to the power, multiply by the reciprocal of the new power, so multiply by 2. You'll get a negative, the little guy stays. I don't know if that helps anybody, if half of you ignored it, if all of you ignored it, whatever, but that's the other way to look at it. Yeah, I think I explained it to you too soon yesterday. I should have let you grasp one method, and then before you fully grasp it, I was like, here's this other one. I should have waited. Yeah, so I think you might like it better now. What else? Were there even other ones? Yeah. nice method. Alright, so that would be my little guy. That's my big guy, and the question is that my little guy prime? And it actually is. Like it's set up that way this time. So I don't have to make any adjustments. That is my little guy prime. So I'm good. And then little guy prime just dies. You integrate the big guy. So the integral of a 7th power is an 8th power. Multiply them by the reciprocal. Leave the inside alone. Put your plus C. Highway is definitely faster. It's less steps. It's just when you get to calc 3, it might not be what's going on. So I'm trying to show you if and when you get to calc 3, right? I don't know if any of you are even interested in going that far. Other things. Do this one with the other method. Do a different problem. Okay, so if I make tan the big guy, what's the derivative of tan? Secant squared. Can I turn that into secant squared by multiplying it by a number? I can't. If I make cos the big guy, what's the derivative of cos? Negative sine. Can I turn that into negative sine by multiplying it by a number? Like I can't do sine times 4 equals tangent. Like I can't just multiply by a number and turn it from sine to tangent. So it's neither. That doesn't work in this one. What else could I do? Tangent is sine over cos. No, there's no big guy, little guy. What happens to the cosines? What's the integral of sine? Negative cosine. So that's your answer. So you don't actually need the reverse chain rule for this one. That's hard to see. Like you're used to looking big. That's why you couldn't find which one was the little guy because there's not a big one. Yeah. Other ones? Do it a different way. Do it again. Do anything. Okay, let's look at definite integrals. So I'll just do one. Like I'll make one up. You got a blank page nearby in that book. Alright, let's say I was integrating x squared minus 1 times x times dx. Sorry, I'm saying it weird, but that's the problem I want you to do. And then we're going to go from 0 to 2. I don't know if I'll even finish this problem, but once I show you like the trick for u's, that's really all we need. But we'll see. So I'm going to go through, like, I'm not worried about the zeros and the 2's yet. I'm going to go through and say, okay, u equals the little guy. We'll add 0 to 2 of x times x squared minus 1 to the 4th. Okay. So u is the little guy. So u is your x squared minus 1. So du is 2x times dx. But up here I have x times dx. So I need to multiply this by some number to turn it into x times dx. What's that number? Half. So I'll add 1/2 du equals x times dx. With me there? So I'm going to go back and rewrite it, but don't write these yet. Don't write the 0 and the 2 yet. So I'm going to go over here, and x times dx becomes 1/2 du. This becomes u to the 4th. But we cannot use the 0 and the 2 anymore. So this is like the trick with definite integrals with u substitution. This 0 and 2 applied to the x values. We just changed everything in the problem to u values. So we have to change these also. So u, I know u equals x squared minus 1. So what I'm going to do, this was x is 2. So if I plug 2 into my u equation, 2 squared minus 1, that 2 turns into a 3. So x is 2, but I'm doing the problem in u's now. So I have to figure out what this number is, what u is when x equals 2. So for the bottom one, which is 0, what number am I actually going to put right here? It's a negative 1. Because I know that u equals x squared minus 1, and then x is 0, so I put a negative 1. And then I can forget the x's even exist. It's like this is your problem now. We don't have to do substitution anymore. We don't have to plug in x's anymore. We're just doing this problem. So we integrate. So add 1 to the power. Multiply by the reciprocal of the new power. So what's the reciprocal of 5? 1/5 times the 1/2 in front is 1/10. You'll have from negative 1 to 3. And then do we remember what to do with those? Plug in the top minus plug in the bottom, right? So that's fine. So it would be 1/10, 3 to the 5th minus 1/10 times negative 1 to the 5th. And I don't really care what that is. I just want to show you how to change the numbers. Does that make sense what I did there? So let's go back to one in your. I'll leave it up because people are still right. But let's do one of the ones in your homework then. Does anybody still need this? I can wait. All right. You're ready. Will you actually go back and look at it? Okay, cool. A lot of kids have good intentions when they take the picture, but. So let's say number 13. That's got a definite integral and it's got trig, which freaks everybody out. Remember, you can skip 4. Did I say that? You can skip 14. You can skip 14. I think I told you yesterday. Okay. So, sine of 2x. So u is the little guy, which means u is equal to 2x. Sine's the big and 2x is your little. So du equals 2 times dx. So what I need this to say is, like, there's no number there, right? So I need it to say 1 times dx. So, because that's what it says up here, is like there's a 1 up there times dx. But right now it says 2 times dx. So what do I need to multiply by? It's a half. So I'll get 1/2 du equals dx. If you're doing it the other way, like the way I was trying to explain, just quickly showing how they relate. The derivative, that's your little guy, is 2x. What's the derivative of the little guy? It's 2. So we'd write a 2 there, but more importantly, we'd write a 1/2 on the outside. And that's the same as 1/2 as this. You're just getting to it like a different way. So if I rewrite this, I will have a 1/2 on the outside, du over here, and then sine of u times du. But I'm not going to write 0 and pi over 2 because 0 and pi over 2 are x values. The problem's not in x's anymore. The problem is in u's. The problem is u. So you're going to plug into this. So if x is pi over 2 and u is 2x, then what number goes here? Pi, right? 2 times pi over 2. You with me? It's pi. Oh, that's the same thing. Yeah, yeah. 2 pi over 2 is fine. And then what goes here is actually still 0, right? Because 2 times 0 is still 0. And now, like, none of this matters anymore. X's don't mean a thing anymore. We're going to do the whole integrate sine, which is negative cos. And then I'm going to plug in the top minus plug in the bottom. So cosine of pi, so from your perspective, pi is over here, and cosine's the x value. So what's the x value over here? It's negative 1, but it's a negative of that. So it's 1. Minus a negative is a positive. So I can just, like I already did these. So then cos of 0 is the x value over here, which is 1. So you get 1 half times 2. You have to do, like, you could stop here. You can leave addition, subtraction, multiplication, division, like the 4 main ones. But if you have trig, or you have, like, powers, those you have to take care of. So, like, because I had cosine, I had to go. Is that all for 13? Mr. Davis method will just get to here a little bit faster. So I would say big guy is sine, little guy is 2x. So I need the derivative of the little guy to be in the integral. So I'm going to put a 2 in the integral just to make that match up. But if I put a 2 in, I have to put a 1 half out. Actually, yeah, now you're just doing the whole problem in x's. So if you do it my way, you're using x's. So you would have to go, okay, that's negative cosine of 2x. Use the 0 and the pi over 2. And then go through and plug all that. Does that help?
Yes.
That is sort of a downfall of my method that I forgot until right now.
Right. Because I was trying to do it, I was like, but we're still in x's. We're not.
You're still in x's doing it my way, so you just do it in x's. So for tonight, what I would want you to do is 13 through 20, but you can skip 14. I'm not worried about like the AP ones. And then I'll show you what I have for tomorrow. So tomorrow is just like a work day for you. I'll answer questions on this, which might take half the class, and that's fine. You'll have time to finish up your con, and then I'll show you what I made. If you go to the Schoology page, I made this topics for review thing. So I went through, and there's 10 little sections here. So like this is one problem. You'll have one problem on accumulation of change, which is from 6.1, and then I tell you like specifically which problems you should be looking at. You'll have one Riemann sums problem. You should know left, right, mid, and trap. Number 3 through 11 are good problems to look at. So I just go through like all. Let me just double check. 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 types of problems. You'll have one of each. I have to tell you like where they are, where to look for them, so you know what to study. So tomorrow's work day for you. Friday I'll give you a full practice one, not graded, no pressure. Just like let's see where we're at. And then Monday it starts. Monday it is on.